Welcome to Demonstrating Implementation Excellence, the stream of the SNOMED CT Expo 2023. My name is Kai Keeley, and I'm the Implementation Support Specialist at SNOMED International. I'll be moderating today's session. All questions will be answered at the conclusion of the presentation. Can I ask online attendees to use the Q&A button to type your questions? I'm now pleased to introduce Nat from Mahang Dong University, Dol, who will be presenting development of a Thai interface terminology linked to SNOMED CT for diagnoses and clinical problems in primary care. Nat, please go ahead.
Thank you. I would like to use this opportunity to thank SNOMED CT for letting SNOMED newbie like me to talk in the big event like SNOMED City Expo this year. My name is Nat Tangchitnob. I'm working as a medical doctor and also start doing masters in clinical informatics at Mahidol University, Ramathibodi Hospital. And also, I'm a member of the Standard and Interoperability Lab Thailand, which we mostly do the maintenance of our country's medicines terminology and laboratory terminology. And also, we are acting as a national release center for SNOMED CT. So I would like to start with introducing our country. This is Thailand, not Taiwan. People usually confuse a lot. Thailand is in Southeast Asia. We have been member of SNOMED International since last year. So my country is also a newbie, just like me, and thus we have universal coverage for all citizens, which means Thai citizens can receive healthcare services for free. For the digital health governance, national digital health, we don't have a governance agency yet, but we are still establishing. For the health data standardization, there is some scene in the some part of the country. So usually, right now we have a code systems that is used nationally. For diagnosis, we use ICD-10-TM, which is time modification. Posture, we use ICD-9-CM and ICD-10-TM, which means there is no one terminology used for posture yet. And for medication, we have developed our own Thai medicines terminology. For the laboratory, we have Thai medical laboratory terminology, which the TMT and TMLT is maintained by SILT, or Standard and Interoperability Lab Thailand. So for implementing SNOMED CT, since last year we are trying to figure out how should we implementing SNOMED CT, since we don't have the political power to force implementation of SNOMED CT to the country. So there are criteria. First, it should be implemented without increasing burden to the clinical practitioners. Second, it should be able to handle Thai language. And three, user interface should not be affected when SNOMED CT is updating, which we update a lot. Okay, so we are trying to look for other country that is not speaking English, how they're implementing SNOMED CT in the country. And we found that one strategy is to use interface terminology, then map to SNOMED CT, and then could be mapped into other terminology after that. So, what is interface terminology? We can be called many things, can be called colloquial terminology, application terminology, entry terminology. It's up to the objectives of the terminology. So we think that interface terminology can first maximize the efficiency of the data entry by have a rich synonymy and level of details of as same as a national language, and enhance usability of SNOMED CT by adding more synonyms and mapping to the formal concept representations. Third, we think that it could promote accessibility to the healthcare providers because it uses familiar and human-friendly terms, and it easy and can be used with satisfaction. So after we do some reading, so the lesson learned from previous efforts is first, translation is not working because first is labor intensive, second is time consuming, and the most important one is expensive. Thinking about Swedish version, they use like a lot of money to translate the SNOMED CT into Swedish, and the content after the translation is not sufficient to cover the term that is used in the clinical practice. Second, we found that the terms should be harvested from living sources of clinical languages, and balance between pre and post coordination should be balanced, and the balance is very hard because it requires both clinical and terminological knowledge. And last one is the mapping. Lexical mapping to the terminology concepts is not equal to the meaning of concepts. So we are trying to, since we wanted the term in the terminology to be the same level as the natural language, so we should extract the term from the electronic medical records. So we find some open source tools for concept extractions, which is here. 3 of them cannot work with Thai language. Like they will treat Thai language as a unknown input. So the Thai language will be like not input into the system at all. So there are 2 of the tools that is possibly work with Thai. So the first one is Core NLP, developed by Stanford. This can work with Thai, but because the types here is the supervised NLP, supervised machine learning, so it cannot be customized to our own data, or because it's like the machine is learning from the correct answers that was provided to them. So if there is a new data that they haven't seen before, they won't be able to handle it. So the one that we think inspire us is the MedCat. Thank you, Anthony. I think you're the one that is developed this. Okay, so they used a dictionary based on the UMLS, which the problem that it cannot work without data is because the algorithm of the MedCat needs the target terminology to be having the language that is used in the source language, source text. So in the UMLS, we don't have Thai content, like very minimal. So none of this is working with our data. So what is our approach here? So we are trying to extract terms from the EMR. In this case, we are using the data from family medicine and emergency department that was representing the primary care, and we're using internal medicine to have a more lexical coverage. And then we mapped to SNOMED CT concepts, which we used from, we used like two tools. First, we are using the MetaMap from National Library of Medicine. And the second one, we use a semantic textual similarity using the embeddings from large language model. Here, as you can see from the term extraction part, the blue one, first we remove the duplication and missing, which is cleaning the data. And then we do the data pre-processing. First, we do the text normalization for English and for Thai language. And second, we do the tokenization, which is our first roadblock, because there is no tokenization for the text that is having both Thai and English, like mixing together. So see our data, this is like, we have Thai about 50% of the data is much more than English, actually. And the characteristics of Thai language is it has no boundaries for words and also for sentence. So we have no full stop, we have no like white space between words. So everything is just like series of syllabus. And we have a syntactics of every type. We can do every type of syntactic, and we can understand what we are communicating. So we are very, for like, when I jump into this, I thought it was going to be more resources than this, but actually for Thai medical corpus, there is no Thai medical corpus available, and also Thai NLP models were trained on non-medical corpus. So if you are familiar with the NLP field, you know that if the training data has no similarity of our data, it will not be working. So this is here the sample of our data. As you can see, not only they have two languages, they mix like together, very well blended. You have like 4 words of English and then like series of Thai languages, and then after that, if you have 10 words of English and then Thai language again. So this here, I don't think I think you cannot understand that, but this is having no sentence boundary and lots of local acronyms and lots of misspellings, both Thai and English. And word tokenization of Thai and English medical text. is non-existent. So we're trying to use the Thai tokenizers that we hopefully could be working for English language too, but nope, not working. So we have to develop, first we have to develop our own tokenizer. We adopt the dictionary-based maximum string matching to be our like tokenization techniques, because it's dictionary-based. So it means that the more words that is included into the dictionary, the more accurate the algorithm works. So here we have problems, 3 problems that if you work with dictionary-based algorithm, it's like the main problem. First, the local abbreviations and acronyms. So we extract the capital letters from our data and using unsupervised learning to cluster them to indicate the possible senses. And then we manually review each one. And then we add that to the dictionary. The dictionary we use to handle the out of vocabulary problem is we use first the English word net, which is a very big English resource, and then Thai word net to incorporate Thai English. And then we tokenize the SNOMED CT descriptions and include that into our dictionary too. And then we have Thai medicine terminologies. We add that into our dictionary too, because there will be like some local Thai medicines. And lastly, we add the local abbreviation and acronym dictionary, which we gather from the first one. Then we handle the misspellings and form variability by lowercase the English letters and lemmatization of English words. And then we fix the misspelling by using the edit distance algorithm or Levenstein distance to fix the misspellings. So I would like to go back a bit. So we can now handle the tokenization problem. Then after the tokenization problem, we then produce the n-gram, which is a series of words that is occurring together. And then we apply the rules to filter the word that we don't need by removing the stop words and removing the grams that contain more than 50% of stop words. Not only the stop words that we are using, we also include the numbers and also punctuations and also some Thai words that we know that it's clearly not clinical words. And then after that we keep the clinical terms we have another dictionary for the clinical tokens. So then we have the interface terms, we could use that as an interface terminology. And then we at CT, which we found a lot of challenges. First, the wrong translation, like the first one, "Na biao" is Thai. It translated to crooked face, but it's actually facial palsy. Or the second one, "Hop Ngai," is translated to razors, which I don't know why. But the correct terms is dyspnea. And then we have homonyms, which is the same spelling but different meaning, like ซึมcan also mean drowsiness or seeping, like water seeping, or the local acronyms. The acronyms that is ambiguous, like PR, can be pulse rate or per rectal, something like this. And the next one is the assertional knowledge, which is one feature of interface terminology. It is like the word that is used in different contexts can infer different things. In this case, like ปวดท้อง is translated by Google to stomach ache, but the meaning that ปวดท้อง means in the context of healthcare, in Thai context of healthcare, is more similar to abdominal pain more than stomach ache. So it's something like this. And lastly, which is, I think Miss G already talked about it like last session, the terminological challenges, like a lot of matching, like one-to-one, one-to-many, and everything of that stuff. And even like some words can be found, the result can be found like hundreds of similar words. So to handle this, right now, we are manually handling it. So to tell you like the truth, that this project is now ongoing. We can still not be able to map all of the interface terms that we found. And we also try using the large language models that is very popular right now, that is GPT, everything. So the zero shots and few shot learnings are the promising abilities of large language models for every task, including clinical concept extraction. We try using ChatGPT-4, which perform almost like very good. But here, there is limitation. First is the token limits. ChatGPT accept about 4,000 tokens per transaction, but some records could go over like 5,000 tokens. And the pricing, they are priced according to the number of tokens. So in English, the token is like a word. One word is supposed to be one token. But in Thai, every syllabus is one token. So the price can like through the roof. So that is also one of the limitations that we cannot use ChatGPT for doing every clinical concept extraction for Thai medical records. And the last one is we are having a privacy concerns because ChatGPT is processing over the API, so we have to send out data to the OpenAI and then we receive the response back. And we here are using the real clinical patient data. So next, we trying to explore some open source large language models, which we found a similar problem, which is the token limits. And mostly they are pre-trained on English-only datasets. We have two Thai fine-tuned model on. We have Thai models, two Thai models. One is based on Llama, and the other one is based on XML. So the problem is they are not trained on a medical text, so it can be useful, more useful than the model that is not pre-trained on Thai text, but it's still not good enough to represent the context of medicine. So we are using the semantic textual similarity based on the embeddings of this Thai fine-tuned local large language model. So I'd like to conclude it here. First, the localization of using the user interface terminology can promote adoption and usability of SNOMED CT. Second, interface terms should be harvested from user's natural language. And third, the assertional knowledge is one important feature of interface terminology. Next is large language models right now has limited capacity for the low resources, language like Thai and maybe others like more lower resource than us. And NLP for low resource language is like an understudied field. So that's all I would like to talk about. Thank you for your attention.
Thank you, Nat. Is there any questions in the room? Yeah, please use the microphone. Thank you.
Thanks, Nat, for this presentation. And as someone that works with clinical data, I do not envy the problem that you have, not just having doctors writing messy clinical records, but also having multiple languages in different scripts as well. So that's a challenge that I'd rather you have to tackle with than I do. But I was wondering, do you think there's a reason for that? Do you think there's a reason why medical records in Thailand are written in multiple languages? And what I mean by that, I'm trying to get at is, are there some terms in Thai that just can't be translated? And same as vice versa. So will that, that's my start with that.
Okay, so if you look at the example of the data that I showed earlier, the Thai part mostly is describing the patient's information, like the symptoms, the clinical problems, something like that, or the like family situations. But in the English part, it usually describes the laboratory of the patient and medication that they're having, something like that. So I think that is why we are trying to focus on clinical problem right now, because we think it's the most part of the Thai language that is presented in the EMR in Thailand. And there's another question, right?
I'm going to need to wrap up the session. We've just sort of run out of time. I thoroughly enjoyed that, and again, I don't envy you either. You've got so many different problems piled on top of each other, and it sounds like you're doing a great job there. I do hope you end up with terms that really represent the meaning of the concept and not just translating something. As you said, that's so important. And of course, that's the guidance for, even if you're translating from the SNOMED English terms into your language, is still the guidance. A really interesting approach you're taking. And good luck with the project. Thank you very much. Thank you.
Thank you.